Let's look at the domains of functions when we combine them. So when we add or subtract or multiply them. We're going to look at three functions. F of x, which is a quadratic function, and that has a domain of all real numbers. So its domain is minus infinity to infinity. G of x is a square root function, or a radical, and you know that anything underneath the square root needs to be greater than or equal to 0. So this function has domain minus 1 to infinity. And last, this is a rational function. We know that we can't have 0 in the denominator, so the domain is minus infinity to 3. We're going to leave out 3, and we're going to make a union of that with 3 to infinity. So what happens when we add f of x and g of x? So if we look at what the function itself, the formula looks like, we see that we still have that quadratic part, and now we have that square root part. So we still cannot include anything less than minus 1, but this value of x can be anything still. So the domain of the sum is the intersection of those two domains. So it's considering the domain that's more restrictive, and that's the one that is being considered. So let's look at this graphically. So here's f of x, here's g of x, and we know that the domain of f of x is all real numbers, so any value of x along the x-axis here. But the domain of g of x starts at x equals minus 1 and then goes on to positive infinity. So I can't put anything to the left of minus 1 into g of x, which means I can't put anything to the left of minus 1 into f plus g. So I'm going to look at the graph of f of x plus g of x. So you can see that it doesn't go to the left of minus 1, but it goes on up to infinity. So this also has the same domain that g had, the more restricted one. So now let's look at f of x and h of x. So if you remember back to sets and intersecting sets, since the domain of the rational function is a subset of all the real numbers, when you intersect a set with its subset, the intersection is just the smaller set. So we're going to expect that the domain of f of x plus h of x is going to be the domain of h, because this is the smaller set. We're taking the real line and we're throwing out the number 3. So if we go down and look at what the formula for f of x plus h of x looks like, you see that it still contains that fraction, so we still cannot have x equals 3 in here. This can be any value. So I'm going to take the intersection of each individual domain, and I just end up with the more restricted domain, because this domain, this set, is a subset of this one. So now let's go look at the graph. I'll turn off these other guys. So here's f of x, here's h of x. So notice that x equals 3 is an asymptote for h of x. So when I add these functions, I see that I still cannot put x equals 3 in there, and that's what the graph looks like. So now let's go back, and the hardest case is when I add g of x and h of x, because now neither one of these has a domain of all real numbers, and neither one of these is a subset of the other. So when we intersect them, we have to think about restricting them so that we don't include any members of one set into our intersection. So let's go down here and look what g of x plus h of x looks like. There's that square root. There's the fraction. So when I intersect both of these, this one, I can't include any numbers to the left of -1. So that's this left endpoint. And for this one, I know I can't include 3. So I'd start at -1, I go up to 3, but I can't include it. So then I have that break with 3 to infinity. So that's what the intersection of these two look like. So I'm going to go back over here to my graph. There's g of x, there's h of x. So the graph of their sum is not going to include anything to the left of -1, and it's not going to include x equals 3. So I'm going to go turn those off. And here's that graph. Notice that it starts at -1. There's nothing to the left. It starts at -1 and goes to the right. It does not include x equals 3 because there's that asymptote, but it includes all real values to the right of 3. So I hope that helps clear up how you find the domains of combined functions. And this would be the same thing. The domains work the same way, whether it's multiplication or subtraction. You take the intersection of the domains.